On the second problem, we have somebody sprinting 40 meters, accelerating for 3 seconds to maximum velocity, then maintaining the maximum velocity for the remainder of the 40 meters, finishing the 40 meters in 5 seconds. What's the acceleration? What's the maximum velocity of this sprinter? Well, we can parameterize this situation either in terms of maximum velocity or acceleration. I've chosen to parameterize it in terms of maximum velocity, and I do recommend that you solve a similar problem if you missed the text problem of similar nature in terms of acceleration. Okay, so parameterize in terms of acceleration if you're not completely sure of this. Now, if the maximum velocity is vMax, then one thing that's clear is the acceleration is vMax minus the initial velocity, which of course is 0, divided by 3 seconds, because the runner goes from rest to maximum velocity in the 3 seconds. Now, we don't know what vMax is yet, but we do note that we're going to be able to find the acceleration if we can find this. Now, I'm going to say delta S for the 1 to 3 second interval is what? We're assuming uniform acceleration, acknowledging that uniform acceleration is not really expected in this case. People don't accelerate uniformly, especially if they're trying to get someplace in a hurry. So, if the acceleration is uniform, as a first approximation, that's going to be our assumption, then the average velocity is going to be maximum velocity plus 0 divided by 2. And we take that average velocity, we multiply it by 3 seconds, and we get the distance that we travel, or the displacement, during the first 3 seconds. And I said 1 to 3 seconds. I think it might be better to say 0 to 3 seconds, don't you? Okay, 0 to 3 seconds. Now, the 40 meters is then going to be the distance traveled in the first 30 seconds, plus the displacement at constant velocity for the remaining 3 seconds, for the remaining 2 seconds. So the distance traveled, or the displacement at constant velocity, is going to equal maximum velocity times the 2 second time interval. So we have the equation 40 meters is the vMax plus 0 over 2 times 3 seconds average velocity for the acceleration phase times the duration of that phase, multiplied by the maximum velocity, which is the average velocity, the constant velocity for the remaining 2 seconds, multiplied, of course, by the 2 seconds. We can then easily solve this for vMax and find the acceleration. Now, I've gone ahead and appended solutions for vMax and acceleration. vMax over 2 times 3 seconds is 1.5 seconds times vMax, and add that to 2 seconds times vMax, you get 3.5 seconds times vMax, and that's equal to the 40 meters, so that we easily solve for vMax, and I believe we get something very close to 11.3 meters per second. Check me on that. And then the acceleration, as we noted earlier, is just your change in velocity during the first 3 seconds divided by that 3 seconds. Change in velocity is vMax minus 0 since we started from rest. I believe that comes out very close to 3.8 meters per second.